Hello, everyone. Good afternoon, yes, and good evening, everyone. Okay, so again, we are here at Sri Chaitanya Educational Institution of YouTube channel. Okay, so here we have been starting what the thing has been going on for the grade 7 right now. We are talking about, and that's a part 2. I told you there's a part 1 and there's a part 2. Okay, more videos are going to yet to come, but this is the part 2 of the session which we are doing it previously also. Okay, so I hope so you have been very enjoying the sessions and all, yes. And the thing is that we are preparing for the one of the best and the one of the largest scholarship examination, as it's been visible on your screen, is that is the score by Sri Chaitanya. Yes, so why this score we are just promoting a lot, because it's a one of the biggest, we can say, the largest scholarship examination that is being given by Sri Chaitanya. Yes, and that's a chance of you to just show up your potential, your caliber. Okay, that's what you can do. So that's a reward. See, the 2.5 crore cash rewards, scholarship is around 350. Then the exciting gadgets and the scholarship of 100%. That's the major part. Now, one of my favorite, as every time I say, that's the NASA trip. Yes, so if I'm going to the student and I have to give this score examination, definitely I'll be just doing that because of that NASA trip, first of all. Then second, I'll be going for the 100% scholarship. Yes, although both are the same thing, because if we are getting the NASA trip, and obviously the ranking is quite good, and that's why we are getting that NASA trip and the scholarship also. Okay, so yeah, that's it. Why. So where we are again starting with the session of this part 2 of the physics 1, which we are already doing the top questions for the with the proper topic and explanation of it, so that you can score the good marks in this score itself. Okay, so we are here with the in Sri Chaitanya Education Institution. Okay, and we are preparing for the score and working for the score examinations. Okay, so here we go. Okay, so don't forget the dates to register for the score. That is exam dates is on 28th of September in this month only, and second one is on the 12th of October. So you need to register on the Sri Chaitanya, okay, score.com. Do it. Link is in the description. Okay, don't forget to do that. Okay, so yes, physics written. Just telling you again, the physics. Okay, you all have been just seen the part. Yes, getting my point? Yes. So here we go then. Yes. So today we are going to discuss the class 7 physics previous year's score questions. Okay, and the topic which I've brought it today are from the topic that will give you the more in-depth knowledge of the particular thing. If you're preparing for the Olympiad, if you're preparing for the score examination or any scholarship examination for that, okay, and it will help you out in your basic conceptual knowledge also. Okay, clear? So here we go. Yeah, so here's the first question is on the screen right now, everyone. So if you want to try, you can try it. Answers are easy, but I'll be giving you the more explanation with this questions and all. So boy starts running. Okay, so here's the question, everyone. Let me check the colors. Yes, here we go. A boy starts running from a certain point P. Where is the point P? Here it is. Okay, and goes round a circle of the radius A. Goes round of the circle like this. It's been showing. It's been going in like this, P to Q. Okay, and reaches to Q with the radius A. With the radius A. This is the part that is the radius, and that's A. Yes. So it's asking, as shown in the figure, exactly the other side of the P, as it's been showing on the figure itself. If it's not been showing in the figure, in the question, if the figure is not there, then always just start to see. Boy starts running from the certain point P and goes round the circle of radius A. So that is the circle. First of all, make the circle of radius A, because it's been saying a radius A and been starting from the point P. That means that it's starting from point P, reaches to Q. Okay, that is Q. Reaches to. Where is that Q? Exactly at the other side of point P. Exactly. So either you go it from this side or you go it from this side. You have to go it till here. Okay, you have to go till here, this point Q. Okay, that is the opposite to it. So distance covered by boy would be distance covered. Distance covered by the boy. So how we can do it? That simple. We all know if the distance we are going to cover over this area, that is also called the circumference of the circle, and that is 2 pi r. Yes, that is the circumference of the circle. Okay, that is 2 pi r. Now in this 2 pi r, this r is given how much? A. Here the r is given A. Okay, so that's what we are doing. We are calculating the total distance. Okay, A. So we will put 2 pi A here. Yes. Now, since you can see it's a semicircle, na? That's covering it from the P to Q. It's a semicircle. From P to Q, it's a semicircle. If it's going to be complete circle, that will be 2 pi r. For the complete circle, it is 2 pi r. But right now it is in semicircle. That means 2 pi r divided by 2. So that will becomes pi r. Just check it. So pi r, we won't write r, we will write A, because instead of r we are having what? We are having the A with us. That is 2 pi A, so it will be pi A. Okay, so answer is option number A. Now, although we can do it directly also, this one, but why we have taken each and every part of it? Because so that we can find the exactness. Now, if in case in this question only, with the distance, if they are going to ask what is the displacement done, what is the displacement done by the body? So displacement is the shortest path from initial to final. If this is the initial point and this is the final, so what we have to find out the distance between initial and final, not round wise, will be a straight one. So if this is A, this is also the radius A, so this total will become 2A. So the displacement will be 2A. And the distance is how much? Distance we got A. So these are the two answers which we can find it out by in the circular one form of motion is being given. Okay, clear? Suppose it has also been added to this only. Like if there is a point, which is going to add like this at certain point, like S, and from Q to S, that is again the radius A only. So what we will do, we will find like this. This we have to find, okay, in that case. But if we not given, so we will be having the more questions on it. Okay, so till here it has been okay, I think so. Clear? So that is the distance and displacement, we can find it out. Now let's go to the next question. In the given figure, okay, now the question is from the electric current, yes. So in the given figure, electric current diagram, which bulbs will glow when the switch is in on position? On position means, listen it here, on position means circuit is closed, and off position means circuit is open. Okay, so right now it is on position, that means circuits need to be closed, and see it's closed. So this is the positive terminal of the battery, that is at the higher potential. This is the negative terminal of the battery, and the current will go from positive to negative, positive to negative. So when it goes from here, it will start to go till here and then gets divided into this, here and here. Okay, so as you can see in the diagram, there is no breakage in the circuit. There is no break in the circuit. As it goes here from B, then A, then comes here, then again, and then move till here. From here it goes, and again it's get divided into two. From here and here, again get added up, and then coming back to this. That means this complete, it's a closed and the continuous circuit is been here. It's a closed and continuous. Always see for the diagram which is being given whether it is closed and continuous or not. Whether it is closed or continuous or not. If it is closed and continuous circuit, then yes, all the appliance, all the load. Sometimes this bulb is also called to be the, or the appliance which is being used is also called to be the load. Okay, it's also called to be load. Okay, clear. So which bulb A, B, C, D, all are in the proper connection, all is working, only the thing which is being given. So that means all the bulbs A, B, C and D is being in working condition and they will glow. Now things to get added up in the question so that you can do the more amount of the questions if they come same type of it. If they're going to ask which one in the series, which one in the parallel, so as you can see, bulb A and bulb B is in series, whereas bulb C and bulb D is in parallel. So this is the one thing, as you can see. Now one more thing to add it on in this, and that's what, if we talk about in series connection, current remain same, but potential difference that is also called to be the voltage changes. In series connection, if the two appliance or the resistance are in series, so their current will remain same, okay, but their potential just changes, like this A and B, like this in A and B. The current will remain same in this through both of them, but the potential for A and B will be changes according to its power consumption. Okay? But when it's come to C and D, in this condition, what will happen? In parallel connection, or in the parallel, if the appliance is being given in parallel, then current changes, but potential difference, I'm writing with PD, potential difference remains same. And see, listen it, this is the only thing like this, because when you are going to study in the more higher grades, now you will find the questions like what? More complicated, where you won't be able to distinguish between by seeing only. So you have to check it whether the current is changing or not, or potential is changing or not. Then only you can just find out whether the connection is in parallel or in series. Okay, so I hope so this much has been clear to everyone for the second one. Okay, let's go to the next question now. Next question is, which of the following statement is correct? Sorry, incorrect it is asking. Yes, it's been asking, it's incorrect. Okay. Let's read the question first. Okay. The size of the shadow changes with the distance between the light source and the object. Okay. This we can say it. Yes, this can happen. It can literally happen, bhai. If you take the source, okay, although maybe that won't work right now, but let me just do it. Maybe it work or not. Let's check it out. Okay. Because already the lights have been there now. So it's not being visible to you all right now. But as you can see, yes, my hand has been, yes, see. So I have just put it the source of the light from here. I put it the source of the light, and this is an object, for example. And if I'm keeping it here, see. So as you can see, if I just go away, so see, you can see the shadow is smaller, and if I'm coming closer to the source, it's becoming bigger. That means the size of the shadow changes with the distance between this light source and the object. Yes. Yes, it do. Yes, it do. Okay. So coming to the next one. So that is the correct one. Take a next one. The dark part of the shadow that receives no light from the source is called penumbra. Okay, here is the something which we need to discuss. Suppose this is a sun and this is the earth, for example. Okay. So the light of the sun will goes on this, and that will be the darker region which we'll get it. That will be the darker region. Okay. Now, and this is the lighter region. So we have the two region for the shadow. Okay, you must have seen in the solar eclipse and all. Okay, this one part. Let me just come to the straight part of the umbra and penumbra, and that is what. So this is the lighter region. This is also the lighter region, or we can say lighter shadow, lighter region. And this one part is the darker one, darker region. Okay, where the dark shadow has been there, and this is called what? Umbra. And this region, which we are the lighter one, that is called penumbra. Okay, remember? Done. So the dark part of the shadow that receives no light from the source is called penumbra. No, that is umbra. It is wrong. That will be umbra. If it is going to be the umbra, then it is correct. Otherwise, it is wrong. So this is the answer which is wrong. Okay. Now, the image formed by the pinhole camera is always of the same size as an object. Think of it. Is it of the same size? Pinhole camera? No. No. It's been saying always. No. If you change the object distance, just like the shadow one which I showed you now, although it's not the same, but the object, if I just move the source, that is a pinhole camera, and the object far and away, so the image will also be the change. Image formation will also change. So that is also the wrong one. During solar eclipse, the shadow of the moon falls on the earth. Yes, this happens. When just now that's a source of light. That's a source of light. Okay. And that's a earth, for example. So in the mid, what will be there? If the moon comes, so shadow of the, suppose this is a moon. Suppose this is the moon. And this is the earth, for example. So this region which is been forming here, this region, umbra one, that will be the more darker one, and that is when that's called what? That is a solar eclipse. That's a solar eclipse. Okay, so the moon comes in between the path of the sun and the earth, and that's called to be the solar eclipse. So you must have go through the topic like umbra, penumbra, then solar eclipse, lunar eclipse, and different phases of the moon. Okay, clear? So this is also correct. That means we have to find the incorrect one. We have to find the incorrect one. So the answer will be, let's erase this. Answer will be this one and this one. That is second and third, second and third, second and third. Where it is? Second and third. Option number D. Clear? Okay, that is the easiest one now. Let's go to the next question now, everyone. Which of the following statement are correct? Before that, we have to find the incorrect one. Now we have to find the correct one. Okay, let's see. Which of the following statement are correct? Let's see one by one. An electric circuit must be opened for the current to flow through it. Just now I told you, it should not be open, it should be closed. It should not be open, it should be closed. Okay, so this, it should not be open, it should be closed. Okay, if you want the electric circuit for the current to flow, that it should be closed. So this one is wrong. Clear? A dry cell, the cell which we use in the remotes of the television, in the AC remote, in the wall clock, that is what the dry cell, mostly the dry cell we are talking about. There are other also, okay? So dry cell, which is been visible, which we see it in our home, that is a dry cell, converts electrical into chemical. It converts the electrical to chemical. You just connect one cell into your toy car, you connected that cell into it, and that starts running, that's the motor which has been there, starts moving it. So what it means? What it means basically? It will be what? That will, it's convert the chemical energy into, because there is some chemical reaction starts to take place in the cell because of the electrodes and the electrolyte which has been filled into it. Okay, like ammonium chloride is there. Okay, so it converts the electrical energy to chemical? No, it converts the chemical energy into electrical one, into electrical. Okay, so that is also wrong. Arey, let's see the next one. Electric current always flows from positive to the negative terminal of the cell through the circuit. Yes, that is something which we are can say is correct. Like suppose, let's connect one electric bulb here. Okay, and then let's connect one battery or the cell, we can say, and let's connect one key here. That's a key. Okay, so we have this various things. This is the cell, this is the key. Right now the key is open, right now it is open. When I put the dot, it become closed key. Okay, it become closed key, and that's a bulb or any other appliance, whatever you want to take, for example. So this bigger terminal is called to be the positive side, and this smaller one is called to be the negative one. This positive side has been at the higher potential, and this is at the lower. What that higher and lower means? Suppose, for example, you have taken two containers and they are at the same base, for example, and that be connected to a one pipe from the bottom, and there is some tap for opening and turning it on and off. Now it is been filled with some colored liquid, for example this yellow till here top, and right now it is off. So what we can say from this diagram, this is having the more potential, this is the higher potential, and this is the empty, so it is the low potential. Okay, after some time, just when I just turn on this valve, when I turn on this valve, then what will happen? Then this water or the liquid which has been there, it starts to move in this one. Until when it will move? Till both the containers get the same amount of water level, like this. That is an analogy we can study like this. So in the cell, this positive terminal, when we buy it from the shop, this positive terminal is having higher potential, this negative terminal is having the lower potential. So current starts to move from positive terminal to and goes like this and towards the negative terminal. So just remember one thing for the other questions and everything. Okay, suppose this is the wire, this is the resistance or the load, whatever you want to take it. Okay, that is the resistance, we can say that is the resistance R, or we can say it's a load like bulb or appliance, whatever it has been there. And if this is the direction is there, so that is the direction. If it is being connected to positive and this is to the negative, so positive, negative, so current, that's called convectional current, that's called convectional current. And just remember, the direction of convectional current is from positive to negative, from positive to negative. Okay, sir, if current flows from positive to negative, then what is the thing which goes from negative to positive then? So in that case, so that is the, if something which goes opposite, and that's one thing only, and that's the electron. That's the electron. Okay, actually the motion of the electron is the responsible for the current. Actually the motion of the electron is responsible for the current in the conductor. But the point is, we have already been in the starting, we have put it that direction of the current is from positive to negative, because see, the electron is around 1834 times lighter than proton. Proton is positive, okay everyone, and electron is negative. Electron is negative. Electron is 1834 times lighter, that means a proton is 1834 times heavier than electron. Just tell me, if on a single bench in a school, 3 of the students sitting, okay, or anywhere 3 of the person has been sitting, and we have to make it move the all one by on, not all, one of them, or 2 students sitting, one having the weight of around 40 kg and another having the weight of around 105 kg. which will become easier to move? Obviously this 40 kg, the lighter one. Okay, so it's just a point, like electrons, the flow of the electron, the flow of the free electrons, how the current move because of the in the conductor, because of the free electron. Just remember this part. In conductors, the charge carrier, we can say, who make the charge to move, that is the free electrons. Free electrons. Conductor have the free electron due to which it conduct the electricity, whereas the insulator have the electron. Insulators have the electron, but the thing is what? They are not free. They are tightly bounded with the material or with the atom itself. So something which has been tightly bounded won't lose it, because if we want to break that bond of the electron with the insulator, we need to heat it up, we need to rise the temperature of it. At that particular temperature, what will happen? The material will start to get damaged, but then there are the chances that it will go and not, it will break or not, but material will be damaged. But in the conductors already have the free electrons in it, due to which it can conduct the electricity. Remember, due to which it can conduct the electricity. I hope so this much has been getting clear to everyone. Yes. Now, so this one is also done. Electric current always flows. That is the true. That is the true. Pure water does not conduct electricity. Yes, because pure water do not have any ions. Ions means positive and negative, cation and anion. Positive and negative, cation and anions. Okay, let me just tell you this thing in the next one question. Okay, so the answer is which one now? So this is true and this is true. Third and fourth is true. Third and fourth is true. Yes, option number B is the true one. Correct? That is the correct. Both first and second is wrong. Third and fourth is the correct one. Okay, let me just tell you here once. Okay, just a second. Yes, see, if you talk about the ions, okay, in any liquid we can say, or we have been talking about the thing, that is what? Pure water. Okay, for the pure water. If you take a tumbler, filled it with the pure water or distilled water something, and another saline water, that is also called to be the salt plus water, we all know, if we dip the one part here, another part of the wire here, and that has been connected to one LED or something, and that has been connected to the battery, okay, so it will start to glow. Won't glow. The LED won't work. But in this case, if we take the wire, okay, here we have the LED, okay, and that is connected to the battery. Okay, so now what will do? It will conduct the current, so it will glow. Why? What is the reason? So there are the thing like, for example, common salt, we take it as NaCl. So Na is positive, Cl is negative, so it has the ions. So the material the liquid should be having the ions in it, then only it can conduct the electricity first of all. Then suppose if we have the acidic nature thing, like some acid has been there, or acid has been there. For example, you have H2SO4, you have HNO3, you have HCl, okay, or you can have one more, that is the organic one, that is the citric, the organic one, C6H8O7, okay. So these are the acidic medium, that is the very organic one. This is the organic acid, and these are strong mineral acid, strong mineral acids. Okay, so they also have the ions, and that ion is H positive ion. So because of this they can conduct. Similarly, if we talk about the base like, for example, you have any bases like this one, salt only, okay, or this is base alone, we are talking about the salt, okay. So these bases are having the OH negative, bases are having the OH negative ions, so they can also conduct. But if they talk about the salt, so they have like example NaCl only, that's positive and negative, they are also having the ions. But instead of it, if you take the sugar solution or alcohol or honey, etc. It won't conduct. It won't conduct because do not contain iron. Do not contain iron. Clear? Do not contain ions. So why I taught you this one part? Because it's a part, maybe the question may come from this topic part also. Okay, let's go to the next. So a bar magnet dipped in the iron fillings and then taken out. There is an iron filling, the bar magnet has been taken here and dipped into it and just taken it out. Okay. What will be the observation which has been correct? What will be the observation which has been correct here? So see, we know one thing. Okay, so here it is only. Yes. We have this. No, we don't. Okay. So suppose this is a bar magnet and we all know magnets have dipoles. Remember, magnet have dipole. One is the north, one is the south. Okay, always. If you break the magnet into two parts, the number of poles will also get divided. Okay, so that is have the two poles into it. And in these poles, one is the north, one is the south. Okay, so if we used to draw the diagram for this one, like if I just draw the field lines, take a second, just a second. Yes. So here we don't have that much space right now. Okay, so these are the field lines which is being generated by the magnet. Okay, like a bar magnet, we are talking about the bar magnet. So the things which we need to keep in mind is what? The field lines goes from north to south. Field lines goes from outside. Outside magnet, outside it goes north to south, and inside it goes uniformly, and that is south to north. That is north and south. Tick. Then another thing, field lines are crowded near the poles, that is the north and the south. Yes, you can see that field lines are very crowded here. Okay, near the poles. So its magnetic strength is also more. Clear? Is also more. So as you can see, the strength is more where the number of field lines will be more, the strength will be more. So field lines more is at the poles. Now, the maximum quantity of fillings get stick to the ends of the magnet. Maximum quantity of fillings get stick to the end of the magnet. End of the magnet is north and the south pole. At the poles, the field lines are more, the strength will be more, so it can attract the more. Okay, right now it's correct, seems to be there. Then the maximum quantity of field lines get stick to the middle. No, that is wrong, totally. Because see, in the totaling, we are having the gap. The more closer the field lines, more will be the strength. Okay. So the fillings get uniformly distributed. No, that is also not. Here it's having the more, here it's having the more, but here it's not more. It's a lower one case. Okay, that is wrong. The maximum quantity will be strict at the north pole only. North pole, it is true. But not only. It should be north pole and south pole. Then it is correct. Otherwise, that is also wrong. So the correct answer is what? The maximum quantity of the filings, okay, or the iron fillings will get sticked to the end of the magnet always, okay? Because number of field lines is more, And just remember, two magnetic field lines never intersect each other. Just remember, maybe the question may come. Two magnetic field lines never intersect each other. Okay. Chalo, let's go to the next question. That's a rainbow one, very easy one. Everyone knows it. So rainbow has been produced when the sunlight falls on the drop of the rain. Which of the physical phenomena is responsible for this? So see, we have one thing here again. Like suppose we have this raindrop here, and we have the sun here. Okay. Then a light, let's take a white light only from here. Okay. Then we have to make something else of this. So you can just see, we can just draw it with the color black. No, it's not visible then. Let's make the color of white only. Let it make it white only. No issues. That's the oil drop or the water drop. Okay. Now, if the white light goes from the sun, white light from sun, okay, and that is the sun. That's a white light goes from the sun in this direction. Clear? Now, after going this, what will happen? We all know one thing. That is the thing which is called here. Right now we have this air as a medium, and this is the drop. Okay, so both are having the different medium. So when the light goes from one medium to another medium, what will happen? It just get deviate from its own path. That's a bending. It will go through the bending. So it just get bended. Now it won't get like bended like this only. What will happen when it passes from this bending will occur in two things, and that's what it gets bending according to the different wavelength, because the white light consists of seven colors. So according to those 7 colors wavelength, it just get deviated. Okay, so we have this color like one is the red, like this one, and one is the, let's take the violet here. Okay, clear? So that is the violet and that is the red. Okay, so what will happen now? At this surface here, what happened? Refraction occur and the dispersion occur. Dispersion is the phenomena in which the white light splits into 7 colors. Dispersion is the phenomena where the white lights split into 7 colors. Okay, that has happened. The Vivgeo, there's a Vivgeo. I'll just show you what the colors are. Okay, you know it already, but I'll just show you one more. Okay, then at this point only refraction occur and dispersion occur. Clear? Now at this point, what will happen? This just get reflected. This just get reflected. Okay, and been visible like this. So it's been like this. Okay. Whereas this color, that's the violet one, goes like this and move like this. Okay, so if this is the ground for the observer, suppose here is the observer who observed, so you can see one thing here, and that's what here the violet, that is VIVGYOR, that is the 7 color: violet, indigo, blue, green, yellow, orange, red. And here we have, okay, that is the formation. So what is happening here? Refraction and dispersion. Okay, and another thing, this is splitting, that is the refraction. Bending is also been occurring, and the 7 colors also splitting, that is the dispersion. And here what is happening at this point? No light is going out, everything has been getting inside and then get reflected. So it's called total internal reflection. Total internal reflection, and we get the rainbow formation here. Okay, so what are the things which we get it here? That is the refraction and the internal reflection only. So that is the second and third, the option number 2. Now things which you can remember from this one is that we have this VIBGYOR. Okay, that's a Vibgyor. In this Vibgyor, this violet has least wavelength, thus bending is more. Bending is more. Okay, where we are talking about, as you are going up, as you go up, so red has maximum wavelength, so bending is less, which is also called to be the deviation. So violet will be deviate more, the more deviation will be of the violet and less deviation of the red. And as you go from violet to red, the deviation starts to decrease, the more lesser deviation will be there, and at the last of the red it will be having the very least, we can say least deviation. Least deviation. So these are the things which you need to keep in your mind about the things in the rainbow and things related to like the dispersion. Dispersion is what again? Dispersion is basic definition, splitting of white light into its constituent colors, or we can say into its 7 colors. Okay, these 7 colors which you are seeing it here, these 7 color which you are seeing it here, that is VIBGYOR, Vibgyor. As you go here, wavelength increases, wavelength increases. This 7 color arrangement is called spectrum, is called spectrum. That is the arrangement of these 7 colors according to its wavelength. I hope so this much has been clear about the spectrum, dispersion and every part of it. Yes. Let's go to the next question now. The increase in the area of the solid on heating is called, yes, that is called the expansion. Yes, expansion. The expansion of the 3 types. If the expansion in the length, before the length was L, now the length increased to X, so it becomes L plus X. That is extent. Simple is. So if it is been having in the length within the 1 dimension, that's called to be the linear expansion. But if that expansion instead of the length, it's been having in the length and the breadth of the material, that is in the both the dimension, so that's called to be the area expansion, or we can say it's a superficial expansion. That's in the length also and the breadth also. Yes, in the both the things, in the length also, in the breadth also, that is called the superficial. If the expansion is done in the length, breadth and height both, all 3, then it is the volumetric expansion, which is also called to be cubical. Yes, cubical expansion. So what is the question? There is no quadrant expansion thing. The increase in the area. Area means L into B, that is the length and the breadth of the solid on heating. So it's called be superficial expansion. The question may come from the chapter 1 more, is that what? Transfer of heat. Transfer of heat. Okay, that is conduction, convection and radiation. Okay, clear? Let's go to the next now. A lightning conductor. Yes, a lightning conductor. What is the lightning conductor? You must have studied in the natural phenomena and all. So lightning conductor is what? It's a conductor which you all have seen in the top of the building like this, which has been attached. So whenever there is an electric discharge of the cloud with respect to the ground, so the whole light get been attracted toward this tower of the metallic conductor and just goes directly to the ground itself. Why is it so? Because if the conduct of the lightning which is strike to the whole building, it will be just getting everywhere, and there's a chances of getting the electric shock, and very dangerous also. What this lightning conductor do? It's provide the very good conducting pathway. It provide the very good conducting pathway, and directly it's been given into the earth, because earth is a large sink of charge. Large sink of charge it has been there. Okay, so whatever you give, it just get absorbed there only. Okay. So if the light comes and strike it, so instead of going to this building, what it will do? It goes through this tower. Why? Because it has very, very less and low resistance as compared to this one. And current is very clever. It always want to go from the free path where the resistance is very less. And on the basis of this thing, we have made many devices. Like in the ammeter, if you talk about in the ammeter, we put negligible resistance. And for the voltmeter, we put very high resistance, which you are going to learn in the classes again, in the higher grades. Why is it so? Because resistance will block the current. So current, instead of going from the path 1, suppose there are two paths. Here is having this is path A and this is path B. Okay. And here the current is been going. This A1 path having the very high resistance in it, and B is not having that high. So all of the amount of the current will start to flow from here. Why? Because current flows from the free path, shortest path. It always won't. Okay? So that's why the current goes from the lightning conductor instead of the whole tower. So what it's basically doing? Protecting. So it's a piece of metallic wire with the spike through which the current flows. Okay, yes, that seems to be correct. Substance that can be charged by the cloud? No, it's not that. Carbon rod? No. Plastic rod? No. This is a piece of the metallic wire with the spikes through which the current can flow, because it's a conductor made up of the copper or aluminium. Most of the better conductor is the copper only. Okay, so that's the one. We have the plate which has been grounded inside it. The whole process has been there. Clear? So that is a piece of the metallic wire with spikes through which the current can flow. Here we go with the question. The given figure shows the distance time graph for the motion of the two vehicles A and B. Which one of them is moving faster? Very easy question. Which one of them is moving faster? So for these type of the graphs, first of all, see which type of graph it is. It's the distance time graph. Okay. And slope of dt graph gives speed. If instead of it's a displacement, that will give you the velocity. So that will give you the speed. So if you want to find out the speed of that particular vehicle A and B, you need to find out the slope. This is a slope. This is a slope, and that's a speed. Okay. So for finding this one, by just seeing only, what you can do, just see the angle of inclination. Angle of inclination. That's how much angle it's been inclined. So that is this one and this one. So from here, if it is theta 1 and then it is theta 2, as you can see, theta 2 is greater than theta 1. So obviously the inclination angle is more. Now leave it all this part. Leave it all this part. Very easy thing. This one is clear. First of all, more the angle of inclination, more will be the slope, more will be the speed. Now instead of that, let's see here one thing. If I take one small Hot Wheel car, put it here, and one car put it here, which will be getting the more faster downward? Obviously this A1. Okay? So more is the inclination, more will be the speed, more is the inclination, more will be the speed. Simple as that. So A is moving faster than B. Yes, true. B is moving faster than B. No. A is moving the same speed. No. A is not moving. No, that is also not. both are moving. Okay, as you can see, the distance and time both are increasing linearly. That's why. Clear? So let's come to the last question of the session for the today, and still we have the some previous in the mock test and everything in the upcoming sessions, so don't forget to see and watch the sessions. Okay, last question. Assertion is given: mercury is used in the clinical and laboratory thermometers. Okay, reason: mercury does not wet the glass and has the high boiling and the point and the low melting point. Yes, exactly correct. First of all, mercury stands for Hg, and it's the only liquid metal at room temperature. First of all, okay, it has very high boiling point. Yes, it has high boiling point and low melting point. That's why it do not get freezed. It do not get freezed very faster first, and it has the very high melting point. So even if you just put, that's why it's used in thermometers and all, bhai. That is why if you just keep the thermometers, anything in the alcoholic, but not the alcoholic, the clinical one or the industrial one also, mostly in the industrial we use the alcoholic one thermometers, but right now we can use, okay. So if we put into the hot one cup or hot something or to measure the temperature, what happened? It's a metal now, and we know metals used to expand. Metals expand on heating. So that is the reason. And the second thing is, there is other material, but the thing is that density is high. It has high density. And the reason is it do not get, suppose if I just take the pan or something or the glass, fill it with the water and then empty it, there are the chances the water may stick at the corner or at the surface of the glass. Still it will, if I put the tissue there, the tissue will become wet. But instead of it, in the same tumbler, if I put the mercury and just pour it into something else, and then I put the tissue anywhere, not even a single drop of the mercury will be left. Okay, so that is the thing. Yes, so that is the both assertion and reason is the correct one. Assertion and reason is the correct answer, and that's why it's been used in the clinical and laboratory thermometers, because do not get wet the glass and this high boiling point and the low melting point. So please remember these points. Okay, so guys, I hope so. This is the one which we have done it here. Okay, so yes, okay, we will going to do the more questions in the upcoming sessions. As we know, we do it every time. Okay, and the thing is, so let's come to the end of the session. Okay, let's end the class, do the questions, see the topic which I've given, all the things are there. You can revise through the topics. If you want something else, okay, Hindi nahi aati kya? Okay, aati hai Alok. If you want, if you have replied me, then I can say it in the Hindi also, no issues. ठीक है, कोई दिक्कत नहीं है बेटा, हिंदी भी आती है. Okay, you must have told me in the starting, I would have said it in the Hindi. मैं पहले बता देता हिंदी में था तो अगर ऐसा कुछ था. Okay, चलो, no issues. ठीक है. So next time पे I'll just think कि आधा session हिंदी, मतलब bilingual I'll go, हिंदी और English mix. ठीक है, हिंदी English mix रखेंगे. ठीक है. So that is the what last the score we are doing for. Okay, and so please like, comment, share and subscribe. You will all know it. Clear? So don't forget the exam dates. ठीक है, exam dates मत भूलना. 28 September 12th of October को है. लिंक मिल जाएगा डिस्क्रिप्शन में, shrichaitanyascore.com पर भी जाके वहां से कर सकते हो. ठीक है, this is the time to prove yourself, to get the things, okay, to get the 100% scholarship, okay, and everything. Okay, so dates are there again, don't miss it. Okay, in the next session we'll be talking about the more part of it and we'll solving the paper. Okay, so follow us on the Instagram, subscribe, join Telegram, Google Pay, you can download the app and all, Facebook you can connect with us. So that's all for the session everyone. I hope so you have enjoyed the session, और आलोक के से याद रखेंगे कि हम हिंदी में भी थोड़ा सा पढ़ते चलें. ठीक है, अगर पहले बता देते तो मैं आधा bilingual चला जाता. Okay, no issues everyone. So that's all for the today's session. Bye everyone. Thank you everyone.